read it. Okay, read. Okay, now the piston it's get displaced. So what actually happens is like the piston as you supply heat, the gas here will absorb it, will expand. Then as is, the piston will be displaced towards left. Okay, how to calculate the okay, I'll just adjust the diagram. So one more diagram is needed. No, meanwhile you think on it. I'll shift everything here. The piston will get displaced here. This is very simple. So now what is the state of spring forces? The spring here will get compressed. This will get elongated, and there's a thermostat. We'll bring it. Okay, I think problem solved. Very easy, no? Now we'll manage it. Now what is the state of how much it is? Himself is telling it is displaced by distance. X, that one. Time being will take it X, then X I'm going to write it as L by 2. What are all the forces they'll be acting? Both the springs will get along, the right spring will get elongated. This right spring will get elongated. And this will be compressed. So the resultant spring force, okay, here we'll show it. This will be Kx. This will also be Kx, no? Then the pressure here, let it be, what can be pressure? Will it be same or different? No, the pressures will be different. So pressure PA, this will be P dash A. Now equilibrium has reached. Now the temperature of the gas, let it be T delta. This will remain as it is T. Now it is in equilibrium now, piston. After supplying, okay, it is. If you can draw this second diagram, I think, okay, you are in better position. Now what is X given? L by 2. This much is there. Now let's get into energy aspect. What all this heat supplied, where do it will go? A part of it will be absorbed by the gas in the right chamber. Then gas, will it do work in the right chamber? Yes, it does positive work. Gas does negative work in the left chamber. The gas does positive work in the right chamber. The gas does negative work in the left chamber. So therefore, there's a net work done by the gas will be there. Then also some heat absorbed by the thermostat, because the temperature, what all heat generated immediately will be absorbed by thermostat. So there'll be some heat will be that heat we have to find out. So that will call it as a Q. This is what we have to find out. Find the heat absorbed by the heat Q given away temperature T to the thermostat. Oh, fine. Symbols little bit. I think two Qs are there. Small Q, I'll write it. Okay, now I made correction. Capital Q was the heat given to the system. Small q is the heat absorbed by the thermostat. We will write it here because these are very essential. Q is heat given to the system. Heat given away or heat absorbed. I'll write it heat absorbed by thermostat. Don't bother with thermostat, sir. I don't know. Okay, not needed. Just it will absorb it. It will see the temperature of the gas in the left chamber remains constant. So therefore, first energy equation, this is what you have to write. The heat supplied to the system. System means what? Everything. Cylinder, piston, everything. That should be equal to, what is the condition we can write? Rise in change in intensity, work done. Or say change in first. Change in intensity of gas in the right part plus what we can write, heat absorbed thermostat plus work done, net work done, or just write work done by the gas in both the chambers. Okay, this much is there. So all these are, we have to work out one by one. What is unknown thing? This Q is what? Unknown. Remaining all capital Q is given. So what we have to find out? These two things we have to find out. Change in energy of the gas in the right part plus work done by the gas in the both the chamber. This has to be determined. And now some information, what are things we have assumed? Sir, what is this delta T? We have brought it, we have to work out that. Then afterwards, work done by the gas in the both the chambers. How to bring the work done. Okay, at equilibrium, so we'll see that, how to bring that one. So now, shall we write the force? I'm asking you to look at directly, look at this one. This at equilibrium. So net force on the piston should be 0. So then this should be equal to PA minus P dash A P dash minus 2 Kx equals 0. Why 2? Because two spring forces, one is compressed, other elongate. Therefore, the net spring force will be 2 Kx. Now, work done by the gas, what has to be taken? From where to bring? I think these are the forces, no? The gas in the right part does positive work, this force does negative work. So shall we adjust dx to the both? There's a beauty of this problem. I'm telling you this one. You are going to, if you don't think this equilibrium, that's why I wrote intentionally. Here is what the problem will get solved here now. Now, what do you mean by sir dx? As I start supplying heat, the gas, will it absorb heat suddenly or gradually? The gas will absorb heat gradually. Then the temperature of the gas will increase gradually. Then, so it will start pushing the piston gradually, not sudden. It will not accelerate. Slowly from rest to rest, the piston will be moving. That's what the beauty of this equation. What is this? Work energy theorem, initial kinetic energy of piston 0, work done by the gas in the right part, work done by the gas in the left part, work done by the spring force. Why 0? Because from rest to rest, it was at rest, now also rest. As we know some mechanics, we will write it. There's no problem for us. Got it now? This is okay. Now after this, what you are going to do? So this part is what I'm very much interested. Now, what is this left-hand side? It is nothing but work done by the gas in the left and right part. So this is 2kx dx. This what we do, I'll integrate this one. So this will be the net work done. So what do we get? Net work done by the gas equal to 2k x square by 2, or this will become k L square by 4. Net work done by the gas it is. Hope everyone is able to understand this part. This will be, I think, most troublesome, I feel. Next, after this, how to get delta T, because that also we assumed it. Anybody? I want from student. Anybody? Delta T. Anybody? Delta T, how you are going to bring? using PVT. Okay, number of moles will be conserved. So number of moles will be conserved. So can we apply that? Or else what you can do, the same pressure equation only we are going to calculate. Number of moles conserved, of course, you can use the same equation. What is P is equal to? Can you write it as? Because number of moles earlier was N, no? So nRT, because we want delta T into picture. So I'm going to take help of same equation again. Number of moles will remain same, no doubt. Let me once again take help of this. Let me put it here. Now we will see this. So what is P is equal to? P should be equal to nR T plus delta T whole divided by volume. What is volume is equal to L plus how much of length it has moved? L by 2, no? Yeah, the piston got displaced L by 2. Look at one's diagram. Minus of. Okay, this is into A. P dash, what you are going to write? nR. It remains temperature T only. A L minus L by 2. Minus 2 times of K. And what is K is equal to? K equal to, this will become L by 2. Solving all this, I'll get that delta. Delta T is equal to 3K L square 2nR. I think you have to check it. In Aribari, I did this calculation. Delta T is equal to this much. Okay, I think we are in better position now. Okay, let's write all the things. So we know now delta T all. Okay, what is the change in intensity of gas in the right part? Is a monoatomic gas, nR gamma minus 1. Ideal monoatomic gas. So we know nR, N3R by 2 delta T. Delta T value, we know it. Then work done by the gas, we know it. Substituting that all, we'll get the required answer. I'll proceed to the substitution type. So here the symbols are Q, okay, what shall we do? Questions very lengthy, very difficult yeah, to accommodate everything. I'll do this one. Okay, there's about one part. Okay, we'll substitute everything here in this equation. We'll go for one by one. This is Q, change in intensity, N3R by 2 delta T. Heat absorbed by that. This is the unknown thing which you have to find out. Q, work done by the gas, K L square by 4. Delta T value, we know it, substitute. So what we needed, delta T, so this will be N 3R by 2, delta T will be 3K L square 2NR plus 2T. Finally, we have to solve everything for Q. NR, it will get cancelled. So Q equal to NR get cancelled. So this will become 3K L square by 4R. R also get cancelled. So 3K L square KL square by 4 plus this will be 3 nRT plus Q. Okay, this will become KL square, Q minus KL square. Check once I have somewhere ended up equation of this kind. Nine by 4, no? 9 by 4. 10 by 4, 5 by 2. Okay, yeah, fine, yeah. Okay, this will be our answer. Okay, very easy. Some more. Okay, the most important part is that equilibrium equation. I think the whole thing, what I wrote. See the complete description of the problem. This is something very important. I think everything revolved around this one only. A very important idea. Any reason for that? Piston is at rest or piston in equilibrium. Any doubt if you have, you can clarify it. We'll take the next question again. I'll go for next question. This also it's similar to that, but no much calculations. You can manage very easily.